of evil HID devices.
Thank you. Good afternoon, everyone. So today we're talking about malicious HID devices. We will do a short introduction about what it is. First, we are blue teamer for Franck, and I'm a red teamer at Societe Generale. So we are doing defensive or offensive security things. You have some example. The agenda for today, so first a short introduction about HID devices. Why is it interesting? Some attacker perspectives, so what can we do with HID devices? And Franck will do some forensics, or system forensic and hardware forensics on some devices we have chosen on the study this year, and to finish some takeaway.
Okay, so little introduction with some definition and context. So HID stands for Human Interface Devices. Basically, it's a keyboard, mouse, joystick, anything you can use to send input to a machine. Almost 6 years ago, a toolbox of the NSA leaked press, and we discovered that they use for almost 10 years HID implant called Cottonmouth. This implant embed 2 modules with microcontrollers for and some radio frequencies implant. This implant cost at this time almost $20,000, and 10 years later, as of today, the device is far more cheaper. Last month, we saw, as far as I know, the first implant used in the wild on the ATM, and and USB devices used to do an ATM jackpotting attack. So the main goal of this kind of attack is to split out all the cash from the ATM. The attackers need to access physically to the ATM, and then they plug through the USB port a module. And this attack, this was a Raspberry Pi and a Pwn P1 platform. It shows itself as a keyboard to send keystroke to execute a PowerShell script to start the final payload.
Okay, so let me introduce some toys we have played with. So I think you all know the Robotic. It's sold since 2010. It's cheap, $45. It's okay. The form factor is a simple USB key. So you plug it, the payload is launched, it's execute, and simulate a keystroke. The payload is stored on SD card. So basically, it's simple to add new payload, but it's very, very limited. So you plugged it, the payload is launched, and it's over. So we are interested in the WHID Injector. WHID Injector is far more interesting because there is multiple connectivity options, USB, but also Wi-Fi. So the attackers can connect over Wi-Fi to the board and execute commands. So basically some keystroke through the board, and it can simulate serial ports, so you can communicate through serial with the board. And for the future versions, there will be a GSM option, so you can communicate with the board through a GSM network. So it could be very interesting because you have a very wide attack range. So for the hardware, it's Atmega 32 and ESP8266 for the connectivity part. If you want to add payload, so it's just Arduino based, so you compile the main program and you can use a small web interface to store the payload. Payload is stored on the board using SPI-FFS file system. So it's just right on the chip. And so you can launch the payload when you plug the board, or via Wi-Fi. So it's very interesting. By default, it's present as a USB key, but if you have some soldering skills, you can just unsolder the USB part and hide it in the mouse, for example. So this one is very interesting, and we have studied 3 options, and this one is the one with the most possibility. And to finish, USBNinja. So USBNinja is sold since 2018. There is some connectivity, so USB classical, but also Bluetooth, but only to trigger the payload. So it's a one-way Bluetooth communication only between a remote and the board. For the hardware, it's a 80TINI85 and a Bluetooth module. And to store a payload, you have to recompile the whole program and upload it on the board, so it could be a little complicated if you want to change your payload on the fly. And it's very, very expensive. $180 for the cable. It's the visual aspect is very interesting because there is cable, so lightning cable, USB-C cable, etc. That's cool, but it's very too expensive for the limited capabilities of this device. New devices are now existing, so this week 2 new devices appears. So the WHID Elite, I talked about it. It's basically an improvement of the WHID Injector with a GSM module, and a new cable called Evil Crow cable. So form factor is interesting. We would like to study this hardware. So I will let Franck. Sorry, no, it's still my part. So. From the attacker perspectives, what can we do with this kind of hardware? If some of you have seen Mr. Robot, in the season 1, Darlene drops some USB key on parking and hopes that someone will pick the key and plug it on the computer inside the prison. This technique is used mainly by Redteamer, as far as I know, maybe by attacker group. So the payload is a little small, but the payload executed here is just a simple PowerShell web delivery. So you grab a full PowerShell script online and execute it directly. This can be detected by antivirus, MSI on Windows. So there is other option. You can use lolbeans, so executable file already present on the system, such as certutil to decode or download files, bitsadmin, etc. Or you can also drop the file embed directly in your PowerShell payload. So you are limited by the size of the board. I think it's 2 mega maximum for the payload, but you could do something. Another option, only with Cactus WHID Injector, is to use the serial port to exfiltrate data. So on Windows 10, and only Windows 10 for the Windows part, but for Linux it's the same, the serial port is automatically created and mounted, so you can talk with it directly using PowerShell. So this is a pretty crappy payload. The idea is just to read the file you want to exfiltrate, so you have to know it before. You encode it in base64, because if it's a binary data, it will probably break your serial connection. And you try to iterate through all available COM ports, and you write your payload on each port. So it works pretty well. So your payload is stored on the board. Now you have to get back this the payload. Exfiltrated data is stored on the board. So you have to be able to connect on the board to get your payload. So you have multiple options. As I said, with Cactus propose a Wi-Fi option communication, so you can create an access point, connect on it, and through the web interface, get your files. Fine, it works well, it's good. If the range is longer, maybe you can just tell the WHID Injector to connect on the public Wi-Fi, and you connect also on the public Wi-Fi, you go to the web interface, and you can get your files. You want a bigger range, you can use WHID Elite and use a GSM network to connect on the web interface and get your file. And if you don't have access at all, you will probably have to break into the enterprise or pay someone to get your malicious device back to you. So this is an option. Villeneuve, this kind of attack is real, so could be interesting.
Now the analysis part. So all starts with analyze. You can have an alert through your data leak prevention system, or an alert through your CM when it works. Or you have a user coming to you saying that there is a suspicious behavior on his computer. And then you start your forensic job. So this is not conf about full forensics, so I will not stay longer on this kind of analysis. But basically, you grab the user computer, you dump the computer and analyze your dump. You extract some indicators and feed your red team, your threat hunting team, and gather related device, and you repeat this process. On Windows, there is a lot of useful artifacts. For my side, I like to do some timeline to see really all the action that succeed to each other. And when you see this kind of trace, this is not good at all. When you see 3 different USB devices in the exact millisecond appear in your timeline, you can doubt that something malicious happened on the computer. Another good indicators is the Windows event log. In our case, there is some of them that were useful. You have the basic one like PowerShell and plug and play device. But the one were really useful for us is the event ID 225. It means your USB devices cannot be removed because it's currently used. Okay. In your case, the event log shows that it's PowerShell that use USB devices, and USB devices, it seems to be a keyboard or a mouse, and this is not good at all. But it's a side effect, and it could be really interesting. So you continue to analyze your timeline, and you show this another event ID related to PowerShell, and you can see something base 64 encoded. You decode it, and you see this kind of payload. So you know that the attackers target a specific file. You have some IOC to extract. For the USBNinja, for whatever reason, on our test computers that have targeted, the registry database has not been synchronized correctly when we shut down the computer. So when we analyze the timeline, we didn't see suspicious keyboard-like USB device that pop up. And the only source of interesting events was an event ID, the 112. And you can see you have the data, the name in the property, and you can see the kind of really suspicious devices. So we really have to not trust only one tool. And in our case, we check with another tool, and this tool told us that the registry appear to be dirty. So we use the transaction log, you know, the log with a big log at the end besides the registry. And when we mix them and reload them, a USB VID, a PID appears in the HID side, and so we can continue our analysis. You check the VID PID, you make a research on the internet, and really, it does not appear to be a simple keyboard. So at this time, so far, you know that a USB device was used to launch a PowerShell payload. If you have the chance to grab the devices, how you can handle it and analyze it. First thing first, do not connect the USB device on a computer. Okay? Even the best of the best of the best can fail in this trap. And yes, I can hear some of you say blah blah blah, I have a Linux, I don't give a fuck, blah blah blah. USB devices really give zero fuck about your OS, and this kind of device will blow up your computer. The USB killer sends almost 200 volts through USB ports and fries up your motherboard. The proof of concept self-destruct, Mr. Self-destruct from MacGrover, at the best will explode or release some nice gases. So this is a good attention to have, to not connect directly on your computer. So the basic process, to have an external inspection, then an internal inspection, try to make a component notification, and try to play with the hardware to dump the data and try to analyze the dump.
Okay, so for the Robotic case, it's pretty easy, even without heavy skills in hardware forensic. Everyone is able to do it. Basically, you just extract the SD card and launch your favorite forensic tools, PhotoRec, for example. You grab all deleted files and current files. And if by chance you have one or many payload.bin files, it's just the payload of the Robotic key. So you can use some Perl script to get the payload in clear text. So basically the PowerShell script executed or any commands typing. Just remember one thing, the payload is keyboard layout dependent. So if you are in AZERTY, take care or you will get a very, very crappy payload in clear text, so you won't be able to exploit it directly. Basically, this could be also used in case if you use a Raspberry Pi 0, for example, you just grab the SD card of the Pi and you should be able to do some forensics.
In our case, for the WHID Injector, we hide it inside a mouth, and it could be hidden inside any USB device with an space. So if you retrieve this malicious mouth and you open it, you will see there is something suspicious inside. And you try to analyze all the components. When we find the Wi-Fi module and you see some of shield, try to remove it, and you can find something interesting like this flash device. So try to go as the easier first. So in the hardware side, the easier task in this case is to unsolder the flash memory and try to dump it. So let's go. We unsolder it, try to avoid to freeze it, and you solder it back on the breadboard. You connect it to breakout, and you try to connect through SPI pins, and you make some trace, and you try to dump it. In this case, it goes very well. We are able to dump it. And as a reverse engineer, you try to make strings first, of course. And you see that you have some intelligible data with a password. So let's try to continue the investigation. But before, if flash RAM that we used previously don't work, you can use a tool like AdWebus to talk directly to your chip. You grab your data sheet and you find the instruction to read to the chip, to the memory, and you can use directly the AdWebus to send the order to read the data. So now we have the data, we grab inside the dump, and we can find really interesting data. So we have the Wi-Fi configuration, we have some intel about the attackers. For the instance, it's really the pseudo of Arthur, and you'll find some interesting like payload. So the question now is, are we able to grab the extracted file? So the data is stored as hundreds of bunch of chunks of data. So when you recurve them and reassemble them, we can retrieve the extracted data, and in this case, that use just stole our logo. But we were able to grab the data stored inside the evil mouth. So it's a big win for us, and it has been a really interesting investigation on this side. But what if you found this kind of device? You open it again, and this device is teeny as fuck and make really, really pain in the ass to dump. So you try to identify the components, and as you may see, there is a lot of glue on the device, and when you put off the glue, there is no more indication on the chip. Hopefully, the program is on GitHub, so when we grab some info, we found that the microcontroller is an 85, and the Bluetooth module. So for the Titini, the perfect method, the best one, is to validate your method before try to dump the chip, your targeted chip directly. So in my case, I have another one near me for the test. Not the same package, but the same chip. Okay, so you connect to the chip, and you try after to connect on the little one. And this one is really tricky. You have to take your time to do micro soldering. You solder on SP pin plus reset pin. You triple check your connection, and you try to dump it, but for whatever reason, this chip is not detected by your material. You come again, new soldering, triple check, do it 3 times in a row, nothing, and you try to connect directly another device. We have to see if I burn the chip, but I go through my first rule to not connect the suspicious devices on your computer. And fun fact, when you directly solder the pin on the PCB and you hit the command line on Overdude to dump the payload, the contents, the device starts the first payload. So it could be a game over, and you see that interference could do bad things. So at this time, we're still looking what is the reason for the fail, but as far as I know, there is no read protection set. The chip has been powered by 5 volt, and maybe it's too much, but it's unlikely. I think honestly that I burned the chip when I chip it off. So it happened, shit happen all the time. So if you have any idea or feedback, come to us please. And I will try to dump the other one that left. So some takeaways. we will continue to work on the new upcoming device that Arthur showed you. We have as main objective to write a white paper to share as much information as possible, because on 30 minutes it's quite complicated. And we'll try to share the update of our work next year. And last word, there is still a lot to be done in the forensics field on this kind of implant. Nowadays, this kind of electronics is no longer reserved to stage sensor attackers, so be ready for any red team. And the key to success for this kind of investigation is to equipment and practice, and don't be afraid to fail, because this is the base of the life. Thank you for the attention.
Thanks a lot for your talk. Are there any questions or comments? Yes.
Hi, thanks for the talk. For the evil mouse, did it show up as a two mouse with a USB hub, or did you connect directly the mouse sensor on the device?
Okay. I will get back to the hardware parts. Yeah. Here you don't see very well, but there is a hub, a USB hub here. So you have the core device for the mouth, and we split out in two sides the cable, and there is a USB hub. So the WHID injector is not directly connected on the PCB mouse.
Yeah, to answer, I think you have both devices connected at the same time. You have the mouse on the fake keyboard.
I've solved this problem with my malicious mouse because I used the TNC, and the TNC is checking took all the sensors, like the wheel, the move sensor, etc., on the TNC, and it shows only as a mouse on the keyboard.
Okay.
So
cool.
it's less flawed.
A clever solution.
Other questions or comments?
A quick question regarding how did you detect, because you have many people inside your company, how do you detect such so low, we can say, signal inside the mass? Even if you have a SIM, I don't think with a SIM you are able to find any PNP.
No, I think the only solution is to rely on I think EDR detection or the PowerShell script executed or some behavior, malicious behavior, because we talked yesterday night with some people about the detection, and yeah, you probably will be able to do some detection on the typing speed. For example, you should be detect when you plug multiple devices at the same time, but basically at work we have what we call flex office. So we don't have dedicated desk for one people, so you change of desk every day. And the keyboard and the mouse are already connected, so on a dock. So you just you plug the dock to your computer through USB, and if this kind of device is hidden under the desk, we can't do anything. So we just have to rely on later step detection, but we know that we can maybe get in the past and detect what happens.
I think we have the time for one more question or comment.
Yeah, good talk. So, imagine you would gather the Windows event data or other data you can gather on all the machines in the institution. Would you be able to recognize the activity if you have the logs?
Honestly, I don't know. It depends of how many logs you have to analyze, and it could be tricky to detect this kind of pattern.
Needle in the haystack.
I don't know. Honestly, I don't know. I'm not on the side of the shim, so honestly, I don't know.
Yeah, and in this case, we have presented we were in the best logs possibilities, I think, and we clearly don't have that actually. So we don't even know if we will be able to do these things exactly with the login capabilities we have now. And if we have to search on all the workstation, we have 90,000 workstations. If we have to search on all the workstations in the company, it will take a very, very long time, probably a too long time. But maybe if we have some patterns, as I showed, we do web delivery, maybe we can just try to grab people talking with the website, and we will be able to detect a pawn computer, basically.
Okay, thank you. And feel free to take additional questions or comments to the cocktail afterwards.
Of course.
Let us thank our speakers again.
Thank you.